In this video, we'll be looking at matching logarithmic functions with their corresponding graphs. So you see I'll have 4 functions here and 4 graphs here. To do this, we'd like to first consider the general form of the natural logarithmic function that we've used in class. We have y equals a ln x, where the parameter a, or the coefficient in front there, has 2 possibilities. Either this a value will be bigger than 0, and it will be positive, or the a value will be less than 0, and it'll be negative. And this will dictate the shape of the graph. If the a value is positive, then we get an increasing logarithmic function. So it'll start down in quadrant 4 and increase as it moves up to quadrant 1. So you get this shape kind of going this way. If we have a negative a value, then the logarithmic function is going to start in quadrant 1 and decrease as it moves towards quadrant 4. And again, turning the same way, but almost like a reflection of the positive log graph. So looking at my 4 options here, I can see I've got 2 negative graphs. I've got a negative 1/2 ln x, and I've got a negative 2 ln x. So those would be paired with either graph 3 or graph 4. Then I need to look at the size of the a value. So I have 1/2 for a, and I have 2 for d. So what we need to remember is that the larger the a value, the faster the y values are going to increase. So in other words, the more stretched out this graph is going to become vertically. So when I look at graph 3 here and compare it to graph 4, I can see that the y values are further stretched out on 4 than they are on 3. In 3, they're kind of closer together. Our turn in our graph is a bit sharper. This one's got more of a gradual turn. So for 3, we'd match that with a, because again, we have that sharper turn that pairs with that smaller value of a in front. And for d, because it's my only other option, I know it has to pair here with 4. But also, if I look at the turn, it's a much more gradual turn, which means the y values will be farther apart because they're increasing more quickly because we've got that 2 in front. So now I want to look at the 2 positive graphs. And I've got 2 ln x and a 1/2 ln x. So I know they're going to be paired with 1 and 3. And I'm going to look at the same thing for the a value again. Again, the larger the a value, the more gradual the turn is going to be on that logarithmic graph, because the y values will be more spaced out because we're increasing a bit more quickly. So this graph is increasing more quickly than this graph. So if I look at y equals 2 ln x, I can see I've got a fairly gradual turn here. So that means that b would match up with graph 2. And if I look at c, I've got that 1/2 value, meaning that the y values are not increasing as quickly as they would be for graph 2 here, so that would have to pair with the 1/2.